Okay guys, today we're going to start in our modules. Our first one we're doing is taking apart numbers and shapes by writing equivalent expressions using distributed property. So today we're going to learn how to write, read, and evaluate equivalent numeric expressions, identify the adjacent side lengths of a rectangle as factors in an area value, identify parts of an expression such as the product and the factors, write equivalent numeric expressions for the area of a rectangle by decomposing one side length into two or more numbers, and apply the distributed property to rewrite the product of two factors. Our first review piece is going to be finding the area of each of these two rectangles. So hope you all know, but in case you didn't, the area formula for a rectangle is just length times width. Now, one thing I always like to do, especially I'm doing any types of these formulas, is go ahead and identify on my figure what they are. So for number one, what do you think the length is? Jamal? 6. Okay, so Jamal says the length is 6. Means the 15 is what? The width. Is everybody okay with that? So here's why I like identifying it on the figure. Now it's really easy to just put it in the formula, isn't it? So now I can say area equals, what did I say the length was? 6 inches. And what did I say the width was? 15 inches. So really all I'm doing is doing 6 times 15, right? So, I'm sorry? You've never seen parentheses used before?
We have.
Okay, so who knows what it means if I have a number, a parentheses, and another number? What does that mean? Awesome, it means multiply. So get used to that. One of the things you're going to notice very quickly, especially about Ms. McShann and I, you guys are going to be getting into algebra. And one of the biggest things we use in algebra is x is our most common variable. So if I'm writing out an expression like this and I see an x in there, now all of a sudden I don't know, am I talking about multiplying or am I saying that there's another value in there that I need to be figuring out? So in order to get rid of that, we're going to start using dots instead of the x or putting them in parentheses. Okay? So we're doing 15 times 6. I do 6 times 5 is 30. 6 times 1 is 6 plus 3 is 9. So I know that my area equals 90, but inches are really critical in mathematics. So you have to have your units correct. What units do I have for this? Yes.
Inches.
Inches, but if you'll notice, what did I do? Inches times inches, right? So mathematical shorthand for that is we use an exponent. We call it inches squared because that means inches times inches. Area will always be in units squared. Does that make sense to everybody? Everybody tracking so far? Okay, so it should make our second one even easier. So what are we going to call the area for, or the length for number 2?
Yards.
No, that's the unit. What's the length? Go ahead. Mm-hmm.
Okay, so is it the top left or the top last time I'll do the one based on the same up and down as that.
So that would be 12. Now, interesting. What happens if I switch this? What if I say this is the width and this is the length?
Same.
I'm getting the same answer, aren't I?
Yeah.
So does it really matter? No, but the key is if you've identified them, now I know, because I heard several people asking, well, wait, don't I just add them? No, what is it if I add them all up? Parker?
That would be perimeter.
That would be perimeter. So by labeling it and having our formula, it should make it easier for you because you know exactly what it is that you need to use, don't you? Does that make sense for everybody? Are you going to get it wrong if you don't put the L and W on your picture?
No.
No. This is just to help you. If you choose not to use the help, but you can still do it, that's fine. This is just kind of an intermediate step to make sure everybody gets there. So again, our formula is A equals length times width. I know now that my L is 9, so I'll put that in, 9 yards times 12 yards. So now I'm just doing 12 times 9. 9 times 2 is 18, carry the 1. 9 times 1 is 9, plus 1 gives me 10. So I know that the area equals 108. What am I missing? Yep. Yard squared. Thank you for adding the squared in as well. And this is just something I was taught at West Point. We always double underline our answers. It makes it very easy to find your answer. So I would recommend doing that in some form. Circle it, box it, or double underline, just so it's easy to find where your answer is. Any questions on our review exercise? You good? Okay. Let's go ahead and turn the page. Okay, Callie is installing a rectangular walkway up to her house. The width of the walkway is 5 feet, and the length is 27 feet. She needs to calculate the area of the walkway to determine the amount of materials needed to build it. So there's really what our task is. So when we say boxing the question, that also sometimes when they're doing directions, box the task. The key is I need to know what I need to do. Everyone should be writing this in your books. Get used to marking your text, guys. And I'm giving you the example to follow along. Okay? We're going to mark and label 2 different ways you could divide an area model to determine the area of the walkway. So here's really our task. We're going to mark and label 2 different ways. So I've given you the exact same rectangle. We've told you what the dimensions are, correct? 27 feet by 5 feet? Should be pretty obvious from the way the rectangles are set up, which side is which. We want you to basically break this length into 2 or more numbers to make it easy to calculate what your total area is. Okay? So label it using the dimensions I've given you. Break these 2, do 2 different ways to figure out how to get your total area. So we'll give you guys about 2 minutes to try to work on this yourself, and then we'll help you if you're not understanding it. But try it on your own first. Okay, guys, we've given you a little bit of time to try to figure it out on your own, but this is tough because you don't have any examples. Let me show you one. So I know that this is 27 feet, and I know that this is 5 feet. They gave us that in the instructions, right? The whole idea is I want to break this into numbers that are going to make it easier for me to calculate. Because 27 times 5, it's not super tough, but it doesn't come right at the tip of your tongue. But watch what happens if I divide my model. What if I make this 7 feet and 20 feet? Is that still 27 feet? It's not? It is, right? But watch what happens. Is it easy for you to do 7 times 5?
Yes.
What is it? 35. Is it easy for you to do 5 times 20? Yeah, what is it? So is it easy to tell what the area of this was? What's 100 plus 35? Wasn't that easy? Now, for those of you that don't like a number like 10, could I do something like this? If it's 27 and 5, could I instead go, okay, well, what if I did 7, 10, and 10? Would that still be 27?
Yes.
Is it easy to do 7 times 5? Is it easy to do 5 times 10?
Yes.
Well, you already said once, yes once, so I'm assuming 5 times 10 is still easy, right? Once I have it, what's 50 plus 50?
100.
Plus 35? Look at that. I got the exact same answer, didn't I? Does that make sense to everybody? Are there other ways I could have done it?
This way.
I mean, honestly, there's a whole bunch of different ways I could do it, right? I could have divided this side into 2 and 3 if I wanted to, but that doesn't really make the numbers easier, so I don't see why I would do that one. But you could have done whatever makes it easy for you. So we actually already did 2 and 3 because we determined the areas of the parts, and we did the total area by putting it all together. Does everybody understand what we did? Is there anyone who's confused about what just happened? Thank you for being honest. So which part confuses you? Nash, right? Nash? What's your name? Zach, that's right. Nash is in my other class. Zach.
We'll divide it by 3. Oh,
Which part confuses you, Zach?
divide this one by 3. And this one like you did it. Same thing. And then you're going to write them.
Okay, so if going back to our original exam, what we did for our opening exercise, right? We know that area equals length times width. So I could have done 27 times 5. But I'll be honest, to do 27 times 5, I'm probably going to have to write it down and try to figure all that out, right? But if I break 27 into 7 and 20, that's pretty easy, isn't it? So I can do 7 times 5, I can do 20 times 5, and then just put it together. So really all I did is I did 27 times 5, but I just broke it into numbers that make it easier to do the math. Does that make more sense? Okay. And one of the keys, and this is what's kind of hard about this one, is I can't tell you exactly how to do it, because you can do it anyway, and it's correct as long as you don't make a math error. Okay? Let's go to our next page. So we're now on page 5. Here we need some highlighters. So highlighters if you have them. If not, you can use a colored pencil, or you can come borrow from the student area up here. But we need something to mark our text, because we have some definitions here we need to write down. Yes, sir. You don't.
That's not a highlight.
Okay, guys, let's go ahead and do this. So here's our first definition, a numeric expression. And here's what you need to highlight. A numeric expression is a mathematical phrase that contains numbers and operations. So there's 2 key pieces to an expression. It has to have numbers, and it has to be some type of operation. Add, subtract, multiply, divide. We're doing something to it. Okay? If I have all those components, mathematically we call that a numeric expression. Okay? The other big one that we're going to do right now is an equation. Hopefully you guys have heard this one before, but just in case, an equation is a mathematical sentence that uses an equal sign to show that 2 expressions are the same as one another. In other words, the values are the same. What many of you may not realize is when you look at an equation, you're actually just seeing an expression written in 2 different ways. It says 2 different things on each side of that equal sign. Does everybody understand the difference between an expression and an equation? Because here's one of the biggest things, guys. You're going to have a lot of vocabulary this year. You have to know your vocabulary so that if I ask you to write an equation and you have an equal sign, you're good. But if I ask you to write an expression and there's an equal sign, are you okay? No, because you did not write an expression, you wrote an equation. If you didn't write what I told you to do, did you get it right? You guys remember our directions test the other day? This is the little kind of things that we're talking about that make the difference. So let's look at our next part here. Reflect on the different ways you can rewrite the product of 5 and 27. We did a few of them back on the other page. Select one of your area models to complete the example. So how did we take apart the side length of 27? We said 27 was what? We broke it into 2 parts. What parts did we break it into? 20 and 7. So instead of saying 5 times 7, I can say 5 parentheses, which means times, right? The product, or the sum of 20 and 7, correct? Is that the same thing? It was the same, right? So now we can say, well, that's the same as 5 times 20 plus 5 times 7. Correct? Because when I took the pieces, I did the area formula 5 times the 7, 5 times the 20. Well, what's 5 times 20? 100. What's 5 times 7? 35. And we found that 100 plus 35 gave us 135.
There's a board right there you can see.
Does it make sense for you guys? Everybody understand where those numbers came from? Okay. We're going to give you guys a chance to start doing this. Okay, we need highlighters again. We have another definition here. And this is the distributive property of multiplication over addition. And that is actually really important because we are using multiplication and addition in this one, states that for any numbers a, b, and c, the equation a times the quantity of b plus c equals a times b plus a times c is true. So this now has its own name. We call this the distributive property of multiplication over addition, because addition is the operation that was used to put the numbers together, correct? And what this property tells us is we can do this anytime and it will always be equivalent. It's the same thing. Okay? So we've given you a mathematical law. One thing on these are property. Properties in mathematics mean that you can do these anytime and they will always be true. People much smarter than me figured this out a long time ago, and we've never been able to disprove it, so it's good. So we're going to skip that one for now. Let's go ahead and go to our next page. Are you ready, Ms. McShann? You ready?
All right, so Mr. Moore just went over the distributive property with you, yes? So the number on the outside of the parentheses means you are doing what to the numbers on the inside of the parentheses? Multiplying. Good job. So this one is 4 times 2 plus 4 times 15. Does that make sense? So you can read that different ways. You can say 4 times the quantity of 2 plus 15. You can say 4 times the sum of 2 and 15. What does sum mean?
It means the answer of an addition problem.
The answer of an addition problem. So that is the same as saying you are adding, yes? And the product of 4 and the sum of 2 and 15. Now we added another word. What does product mean? Multiplication equation, and this is addition. Make sense? And both of those operations are in this problem. So they're using the proper vocabulary. So let's look at the bottom. It says fill in the missing addend in each box that makes the equation true. So you are filling in the missing number to make the equation true. We're going to do one with you, and then I'm going to let you work. So let's look at A. This says 7 times parentheses something plus 10 equals 21 plus 70. What does that 7 on the outside of the parentheses mean?
You need to this from the first that's inside the parentheses.
Not quite. What does a 7 on the outside of the parentheses mean? We have to multiply whatever's inside the parentheses. So I'm multiplying 7 times something, and I'm multiplying 7 times 10. Well, 7 times 10 gives me that 70, right? So what times 7 would give me the 21 in the answer? 3. So 3 is my answer. Does that make sense?
Yeah.
All right, and let's look at number 4. I'm going to do one with you here as well before you start working. It says rewrite the factors as the sum of 2 terms in each expression and use the distributive property to verify each product. So this one we're doing the backwards. They give us a multiplication problem and an answer. They want us to write it using the distributive property. So what is going to go on the outside of the parentheses? 4. And how can I break up that 17 into pieces that are easier to multiply? What does that 1 represent? It doesn't represent a 1. It represents what place value is it in? So it represents 10. So I can break it up into 10 plus 7 because that equals 17. Yes? And when I work out that problem, what do you think it's going to equal? 68. Yes? So let's check it. 4 times 10 is? 40. 4 times 7 is?
48.
Plus 28. 40 plus 28 equals? Does it give me the same answer? Yes. So we know we got it correct. So I'm going to give you about 5 minutes to do B, C, and D on number 3 and B and C on number 4. Are there any questions before you start working? You don't have to ask that. You sign out and take a pass. All right. You may begin. 5 minutes. Go for it. All right, guys. Let's come back together. Let's look at letter B. We know we are multiplying by what number? Oh. We're multiplying by 3, and they gave us the 15, so 3 times 15 is what? Just tell me. 45. So now we're looking for what number times 3 would give us 36. So 3 times what gives us 36? 12. All right. We're multiplying by what number in C? 8. 8 times 2 is 16. So now we're looking for 8 times what gives us 56? 7.
And guys, notice that you're doing these arrows. Please add them in on your papers as well.
Sorry, it's habit. I can't do it without it.
But it's really going to help you. You're going to see this distributive property a lot.
It's
so
habit.
You need to know how to do that.
All right, what am I multiplying by on D? Tell me. 5. I know 5 times 6 is 30. So I'm looking for 5 times what gives me 45? 9. I heard somebody say it. How many of you got all 3 of those correct? Good job. Guys, by 6th grade, you should know your multiplication facts like this. We should be able to ask you any fact 1 through 12, and you should be able to get it. Seriously. All right, B. I need to rewrite this using the distributive property. So what am I going to be multiplying by? 9. So 9 is going on the outside of my parentheses. And how can I break up that 34 into easy pieces? Good job. 30 plus 4. And that should equal 306. Let's find out. What is 9 times 30? 270. It's 9 times 3 with a 0. What is 9 times 4? Does 270 plus 36 equal 306? Then we are good. Make sense? What am I multiplying by on C? 3. So 3 is on the outside. And how do I break up that 29 into easy pieces? 20 plus 9. And that should equal 87. So let's check. What's 3 times 20? 60 plus, what's 3 times 9? Does 60 plus 27 equal 87? Then we are good. Does everybody see how breaking it up into those smaller pieces helps you multiply it faster? Good job.
Okay, let's go ahead and go to our next one. We're on page 7 now in your modules. This one is, we've now given you guys a lot of background, so now is your chance to show us that you're understanding this. So let's look at our instructions. We need to identify each statement as true or false. If the statement is false, show how you could rewrite it to make a true statement. So here's a big piece of the direction. Okay? So you're going to look at it. If it's true, you write true, circle true, you're done. But if it's false, you're going to need to rewrite it to make it true. Does everybody understand what we're doing?
Yes.
Okay, so we've got 5, A, B, C, D, and E. You got 5 problems? Oh, come on. Let's let them struggle a little bit first. Fine. Okay, so if you guys will go back to what Ms. McShann was showing you, if the first thing I do is draw my arrows, it's going to help you immensely on this. Okay? So if I do my arrows, what should I see on the other side? I should see 3 times 2. I have that, don't I? Plus, what else should I have?
So you gotta scroll back up.
No, I wanted to see if you were paying attention.
You're gonna do 3 times.
I'm just kidding. I have no idea why I did that. Miss McShann's playing her Jedi mind tricks again. What's the other part I should have? I have another arrow, right? 3 times 4. Shouldn't I have?
Yes.
Do I have 3 times 4? No. So did they do this right?
No.
No. So what would I circle?
False.
False. Now, because I circled false, I have additional instructions, right? So now I need to rewrite it to make it correct. So it's up to you, but I would recommend starting from scratch, doing your arrows. So I can now rewrite this as 3 times 2 plus 3 times 4.
Because it doesn't say 3.
Does that make sense? Gabby?
So the dots mean
Dots means times. Yep, that's how we want you to write dots from now on. Ms. McShann, I really feel like we need to add a ways to write multiplication into our first lesson here.
I need to do a anchor chart, and I will do that this afternoon.
Okay. Okay, so you have 4 more to do. We just did the hardest one for you. Congratulations. So we'll give you guys about 4 minutes to do the next 4. Go. Yep. Okay, part B, is it true or false? True. Well, let's look. Put my arrows in. I should have 6 times 10. I have that. Plus, have that. 6 times 5. I have that. Yeah, that's true. They did that one right. Okay. Our next one. And again, if we start with the arrows on distributed property, it should make everything easier, right? So the first thing I should have is 7 times 20. Do they have 7 times 20?
No.
So is this right? Nope. So we go false, and then to make it easy, we just rewrite it ourselves. And we say, okay, well, I have 7 times 20 plus, because that's my sign, 7 times 8. So this should have been your rewrite. Okay? What about our next one? Put in our arrows. Do I have 4 times 5?
No.
No? Did they do it right?
No.
it is not.
Because 4 times 5 is 20, right?
Yes.
Can I just skip that step?
No.
Shouldn't. But in case we wondered, is 4 times 10 10?
No.
No, so we know they're wrong because they didn't do both the numbers right. Technically, I guess if they'd have done 20 plus 40, they'd have been okay. But I really want you to see you write those steps out. So this one's going to be another false. We'll do this, 4 times 5 plus 10. So we do our arrows, and we know it is 4 times 5. Our sign is plus 4 times 10. There's our answer. Okay, our next one. Do our arrows. We should have 2 times 6. Is that 12?
Yes.
Yeah? 2 times 11, is that 22? So is that okay?
Yes.
I'm going to put true. I wish they hadn't gone straight to the answers. I would rather have seen them rewrite it. So if you said false and rewrote it the way we told you, I would give you credit either way on this one. Okay? Make sense? Any questions on that page? Right, they didn't write it correctly. They went straight to solving it.
So then technically it is false.
Technically it's true because what they wrote was true. It would be 12 plus 22. But the way they wrote it, the format isn't really what we should have seen. Okay, let's go to page 8. Okay, you can apply this to your property to solve real-world problems. Tyler is setting up the gym floor for an after-school program. He wants to include a rectangular area for playing volleyball and another for dodgeball. He wants to have an area for kids who like to play board games or just sit and read. The gym floor is 50 feet by 84 feet or 4,200 square feet. Create a diagram to show how you would divide up the gym floor. Represent your diagram using the distributed property and write an explanation for the areas assigned to each activity. Okay? So we have a lot that's going on here. We need to create a diagram, and we need to represent your diagram using the distributed property and write an explanation for the areas of each of the pieces. So how many different areas does he need to divide this into? We have one for volleyball. We have one for dodgeball. We have one for board games, or just sit and read. So is that 2 or is that 1? That's actually just one big one, right? So you should have 3 different areas in your gym. 3 different areas. Think about what's being done in each area when you're dividing these up. Okay? So unfortunately, we don't have a whole lot of time left because we still need to go over the homework. But I will give you the initial diagram, which should look something like this. It's going to be 50 feet by 84 feet because it is a big rectangle. We need to divide it to get us those 3 different areas, and then you're going to write your equation using distributed property to show how you do each set. So I'll give you a big hint. The 50 is an easy number to use, so you might want to break this one into 3 areas. Okay? Unfortunately, you only got about 3 minutes to figure this out. So we can cover over homework. So there are, and I will be straight up, there is really no wrong answer on this as long as you've got the math to support it. I actually did kind of like one of them I saw. The only thing you didn't do was switch the end piece. But I would take this, and because I've got the dodgeball and volleyball going on, dodgeball kind of takes a long area, right? So I would actually just kind of break it like this. And I would say, break this one into 2 pieces, because I can do a fairly small one for volleyball. So I'd make that 25 feet by 44 feet. Make this 40 feet over here, and then make this one 25 feet. So that I'd have the volleyball, the games and reading, and dodgeball. The only downside to this is because I broke it 3 ways, it's going to make it a little harder to show the distributed property. But my equation, I would basically break into this one. I would say we did the 25 feet. Actually, we 45 feet times 25 feet plus 25 feet. 44 feet times 25 feet by 20 plus 25 feet for the one side. And then the other one would have been 50 feet times 40 feet. I know. I'll probably rethink that before we teach it again, but that's okay. No, we got to go to, it's time for homework. Okay, here's your homework, guys. Everyone tear out page 9. Tear these out, put them in your binders so you can take them with you easily. Couple quick notes. Journal entry. There is room here.
Guys, you are listening.
All you got to do is tell me how you're using that to compose and decompose numbers. In other words, how are you breaking them up? I'll give you a hint. Find an easy way to do the math. Then you're going to practice. Divide each into 2 or 3 smaller rectangles. Then write each one. So you got 2 parts. You need to divide it into smaller rectangles and then write each area in the form of distributed property. You're doing that for 1, 2, and 3. Go to page 10. Now we're evaluate. Evaluate means give me the answer. So evaluate each expression using the distributed property. Show your work. In other words, rewrite these. Okay? This one gives you a little throw we haven't done. Here is the distributed property piece, and then you're going to add 10 once you have found that answer. Okay? Stretch. This is optional. You do not have to do it. Okay. So good news. Just 2 pieces of homework for you guys tonight, but you may have seen in your agenda you have a second piece, right? Good news for you. This is for your parents. Okay? So your parents also get homework from us tonight. Please have them fill it out. We want these back hopefully by Tuesday.